Good morning, good afternoon, everyone. Welcome to another episode of First Canada Live, a show where we bring together our community and share stories about robots, volunteers, alumni teams, programs, everything and anything you can think of. I'm your host, Karthik Kanagasabapathy, and joining me today is our guest co-host from the First Canada Youth Council, Ishan. And hey, Ishan, how's it going?
Pretty great. Hi, my name's Ishan. I'm from Team 2706 Merge Robotics. I'm in grade 11 and I joined FRC in 2018. I'm extremely excited for today's show.
Well, thank you for being here. And Ishan, we've got a great group of guests. We have two Stories Time segments today. We got one with First Canada game announcer and Team 4476 drive coach, Brennan Bibic. We have another Story Time with Team 188 mentor, Shifa, Abbas. And we have a profile on the winners of the Durham College District event, Team 2200, MMRambotics from Burlington, Ontario. And our first guests are our first tech challenge team. That's right, our first FTC team on the show from British Columbia, Team 3491 Fix It. So throughout the show, if you have any questions for us, join in this chat on Twitch. Pop in all your questions for us, for any of the panelists, guests, hosts, and whoever you want, and we will do our best to get to them on air at some point. But just remember, this show is about celebrating excellence and all that's good in our first community. So let's try and keep everything positive, professional, and let's just keep it in a celebratory mood, because that's the kind of mood I'm in today. It's exciting times here. You ready for this to start, Ishan?
Yeah, for sure.
All right, let's bring out our first guests. They are Team 3491 Fix It from Victoria, BC. They've been competing in the First Tech Challenge since 2009. They've won a host of awards, including most recently the Inspire Award at the 2020 Washington Championship. But they've also won the 2017 Championship Inspire Award in Houston. That's right. And for all our FRC viewers, the Inspire Award is the equivalent to the Chairman's Award where it comes to FTC. So that is basically the highest honor you can win as an FTC team, and Team Fix It has done it. So welcome, Team Fix It. And from Team Fix It, we have Joel, Maithri, Hansen, Ines, and Ishan. So wave, smile, say hello, and take it away with your presentation.
Hello. Hi.
Hello. I love the energy.
Hi.
Okay, so we are Team Fix It, 3491 from British Columbia. So our team does not just compete in BC, we also compete in Washington. So give a little history of our team. So it also creates a nice bond between our team members. So we learn a lot about each other, whether we like it or not, but it's very fun to do car rides together. Can you go next slide, please? So this season, we have competed in 7 different events, and we've had our top finishes that we like to mention. We came first place at both league events in Washington. So we came first in League 1 and 2. And then in the Interleague, we won Capital Alliance, which is the robot game. So we came first place in the robot game. And we also got second place in Victoria. In total this year, we've won 5 awards, including the Inspire Award. And we've done, as like our team does not just like focusing on the robot game. We like to have like a well-rounded team. So we have done 20 outreach events and just lots of connections, engineering connections with the community, because we like to get our name out and just interact with the community to make a difference in first.
Hey, Joel, what do you define as an engineering connection?
So basically going out into your community and touring, like Microsoft was one, different sponsors of places like venues of workshops and stuff like that. Can we go to the next slide, please? So today I'm going to talk a bit about the engineering notebook. So basically how our team does the engineering notebook is that we start with our first page, the table of contents. So we kind of like split up the different sections of our engineering notebook to keep it nice and organized so the judges can refer back to it. And it kind of shows a summary of what we've done that season and shows how much time we put in everything. And then we usually do a team introduction, talk about our hobbies, our favorite parts of the season, and just different things like that, so the judges can have a better feel of our team. And then we have like our robot section, which is one of my favorite sections. So basically, it wraps up our whole robot and all the cool mechanisms. Like we had a really cool mechanism this season, which is a tape measure shooter. So basically, we reversed the player tape measure because this year we had a park in a corner of a taped off square, and the rule was all you do is break the plane. So we made a spring-loaded tape measure that just fires into the corner. And then we do different sections for our outreach and our connections, just because we don't want to have them all together and it would be harder to find. And then the programmer's favorite, the programming section, which is very good for the Control Award, which is the Programming Award, which is what we'll talk about later. And then we have our regular entries for our work days, so what we've done. And then at the end, we have our business plan to show the judges how we stay sustainable and get new team members like over the years. And because we're a community team. And we also have like how we make our money and how we survive to make it income. Can we go? And we also like to tab each section to separate it nicely. Can we go next slide? Yeah. So how we write an entry is that we usually start with a nice little heading. So basically we'll say who was there that day, how long we worked for, which makes it really easy to refer back to our dates when we worked. The entry notebook for us isn't just something we hand into the judges. It's also for something for a way for our team to communicate. So if we made a change on the robot, it's very good. So one of our teamers that missed it could go into the entry notebook and see, oh, you guys did that. And they can pick off where you left off when we meet again. And then we say what we did, who was there, the in time. And then we have something called a reflection in our entry notebook. So basically we'll have our jobs. And then we have a reflection that's something short and relevant or something that you learned that day. It could be something really random that you learned or something like really like deep. And then we have our entries where we just have a summary of our tasks, maybe the changes we made, which is very good for other team members to go back and refer to. And we have pictures of our CAD and our difficulties and solutions and how we solve them. And now I'm going to pass it on to my three.
And before my three takes it away, I just got one question about the engineering notebook. We got a lot of viewers today who aren't super familiar with FTC. They're more familiar with the world of FRC. So is the engineering notebook a mandatory requirement in FTC, or is it highly recommended, or is it just something that Team Fix-It does?
So basically every team in FTC has a judging interview. So every team goes into it. And the requirement for most awards is to hand in an engineering notebook. It just kind of like shows the judges what you've done, and it's good for documentation. So yeah.
Yeah, it's very cool to see. I think it's really cool that at the end of the season, you have like a full synopsis of everything you've done. It's just kind of like, it's basically telling the team history, and that's really nice to have archived there.
Go ahead, my three.
Okay, thanks. So we're going to talk about what actually an FTC judging interview is. So it's really just a set amount of time that you have with the judges, and you have to sort of present a 5-minute presentation, pretty much summarizing the things that you've done throughout the season. This part, something to note about this part is that this is actually a way to entice the judges to read your engineering notebook, not really an in-depth like summary or like explanation of your mechanisms or whatever it is about your robot or activities that you do. And then there's 5 minutes for the judges to ask questions. Teams hand in their engineering notebooks typically around this time, and it's a way for judges to assess what the team has done throughout the season. Next slide, please. So next we'll actually talk about the contents of a judging interview and how Fix-It approaches making our presentations. So first things first, always, which is true for any interview, you introduce yourselves. So typically we come into a room, shake hands, say our names, introduce the robot, give our engineering notebook along with control and documentation, and sometimes we like to give little goodies. Teams like doing this quite a bit. Since we go to Washington State, we like to give little maple candies. A team that's like friends with us actually gives, if you see on my screen, they're called SKIT, Space Koalas in Disguise, and they give out like these really cute space koalas.
I want a space koala.
Yeah, everyone wants them. They always run out.
Who doesn't want one?
There's an FRC team, Team 3132, Thunder Down Under, who from Australia. They give out koalas at the FRC. Not real koalas, obviously, but they give out little koalas too. So koalas are clearly a big thing across the programs.
Oh, cool. So the next
their quality.
Oh.
Pure quality.
Ines wins First Canada Live for today.
Okay, moving on. Next, we have the robot section, which summarizes, it's still on this last slide, thank you. So next we have the robot section, which summarizes all the mechanisms. Again, very brief descriptions of the mechanisms, just because, again, this is how we entice the judges to read our robot section. It's good to mention about the design challenges you had, short and sweet. Just because judges do look for CAD and other evidence of design process when they're looking for criteria for the design award or the innovate award. So it is useful to add that in. Then we have programming, which describes your strategies that you have throughout the season when approaching teleop and the pre-programmed autonomous periods. Next slide, please. I'll pass it on to Hanson with outreach.
Sorry. Fixit does a lot of outreach events throughout the season. A total of 20 so far this season. However, unfortunately, we can't talk about every single event. It is important for us to choose and highlight the events that are most impactful. Example, out of 4 events, Tuasaat First Nation March Break Camp, Vancouver Island Regional Science Fair, School District Career Fair, and FTC Jumpstart Scrimmage, we ended up choosing the School District Career Fair. This was because the career fair had over 1,500 high school students. This was a good opportunity to talk to a lot of students who were interested in robotics and join a first team, which is also a really useful transition into connections.
Okay, thanks, Hanson. So again, unfortunately, since we have so many connections and we have such limited time in an interview, we can't always say, talk about all the connections that we had. So we have to choose to highlight the ones that have been the most impactful to us. So an example would be one time we went to one of our sponsors, MDA, which was the company that so happened to build the Canada arm on the ISS. And we got to talk to an engineer over there, and he was able to walk us through our documentation and show us how to improve it and how to actually create some documentation that would be beneficial for later team members to come. This is also a good time to point out your sponsors, how Fixit does it is by showing all our sponsors on our handy dandy side panel on our robot. Finally, on the last part of our presentation, we have our business plan and closing. This is a the briefest of briefest sections that we have. It's pretty much like 15 seconds long. We say that we have a SWOT analysis, our goals and milestones, and just mention that it's in the engineering notebook and there for the judges' eyes. One thing to know about all of these sections, like the robot section and the programming section, Fixit does not allow builders to actually talk about our robot section or programmers to talk about the programming section, because we want our team members to be able to keep in touch with all aspects of the team, as well as not to get too carried away and get too caught up in details during an interview. Next, I'll pass it on to Hanson with the next part of the interview.
During the next 5 minutes, judges will ask questions that they have. We'd like to use this opportunity to dive into topics that we were unable to talk about during the interview. After the interview and you've had fun in your competition, Fixit likes to review what we have done and how to improve. Most notably, the judging interview. We'd like to think about how we could have improved in our interview. Was there something we could have improved upon to enhance the presentation? How to make the transition more smooth? What we could have left out to save more time? So on and so forth. Speaking of transitions, let's transition to the control award documentation.
It's the next slide. So the control award the control award is an award for a robot's programming. It celebrates a team that uses sensors and software to increase the functionability on the field. Next slide. Oh, actually, no, sorry, same slide. Sorry, same slide. I'm gonna pass it on to Inez. I'm not thinking.
So the control award is special in FTC in that the control award has different documentation than all the other awards. All the other awards, you can turn in your engineering notebook, you do your judging interview, and you're automatically entered for the award. But the control award involves filling out the control award content sheet in Appendix D. Basically, the requirement for the control award is to have a control component on your robot. Control components are programming components that enhance the functionality of the robot. It's not a requirement, but it's a really big thing in the control award is that these control components work reliably and consistently in the field, and that the control components are documented in the engineering notebook.
Ines, I just want to stop you for 1 second. Like, this is such a cool concept that FRC probably needs to have. Just this, because there's a bunch of awards in FRC, technical awards for the robot, but it's just solely based on an interview in your pit, and you don't submit anything for it. But I just think that any FRC team, even if FRC is not going to develop a forum like this, could use this forum and create something and give it to the judges, because this is just like, it's very objective. I like how it's just laid out. You talk about your key algorithms, enhancements. This is cool. I'm impressed.
It's nice because not only do you have to like document everything as you do it, but at the end of the season, like before competition, when you're writing your documentation, you have to go through everything and review sort of your journey through building your robot software and how you've improved it. So it's definitely something that even if you don't have to do, I think I might have done just to reflect on what I've done so far. And then after I've done control board documentation, sometimes it's easier to know what to do next in terms of autonomous or teleop.
Yeah, absolutely. And I think that oftentimes we forget that a huge part of the learning process is the reflection that happens. A lot of people get so caught up in the lesson and application, but I've always found that the most learning comes in the reflection afterwards, where you kind of soak in what you've learned and you try and connect it to other things. So that's really impressive.
Thank you. So one of the sections in the control award application are engineering notebook references. Fixit likes to reference sections of the engineering notebook that have to do with algorithms and sensors and all of that we've already said in the control award. So we'll document, for example, all of our OpenCV code, and then we'll say, see these pages at the end in the engineering notebook reference section. First also says that engineering notebook references it's good if you include stuff like goals, strategies, and requirements for autonomous. So when planning out programming, seeing what your requirement is before you make it, and documenting pages that show robot performance and robot improvements with and without added sensors. So testing your robot when you add sensors and when you add algorithms to know what the improvement was and how it was, and then documenting that. So the sections in the control award documentation include autonomous paths, so bookmarking your autonomous paths, sensors used, algorithms used, engineering notebook references, and teleop enhancements. We're going to go over 2 sections really quickly, and I'll hand it over to Ishan to talk a little bit about sensors. So next slide.
So sensors are used to enhance your autonomous or teleop and make them more efficient. So here we have a list of a couple sensors. The color sensor and distance sensor kind of explain themselves, same with the voltage sensor. The IMU basically just detects the inertia of the robot, and the encoders get the amount of ticks from the motors, which can then be programmed into an algorithm to find the distance. So yeah, the sensors are basically just used to make your program more accurate. And then when you're done programming the sensors, you can document it in your engineering notebook in the programming section if you want to shoot for that connect. And now I'm going to pass it on to Inez.
Yeah, just adding on to the sensors, when we are planning out our programs, we always make sure to look at what our planned path is and know what the most efficient use of our sensors are. Because part of control documentation is saying what sensors have you used, why have you used them. So for example, for passing a line, we'll use a color sensor. If there's a wall, we'll use distance. If we need to use OpenCV, we'll use OpenCV. But just looking at the field before starting programming and sort of what are the best sensors to use for this specific task is always helpful in terms of just getting started. Next slide. So of course, a lot of the time when people think of programming, they think of our autonomous section. In FTC, in case FRC people don't know, we have a 30-second autonomous period and a 2-minute driver operated period. But teleop enhancements are also important, both in control and just in, I guess, controlling your robot on the field. So some examples of teleop enhancements that Fixit has used include signaling operations. So when a certain condition is detected on the field, having a signal to the drivers can help. because sometimes your driver is the most qualified to do something, but sometimes your robot is the most qualified to do something. For example, one year we had, when the robot was picking up balls, the side panels would flash a different color when there was balls in the robot. So if the robot was turned away from the drivers would know when they were able to go and shoot stuff. Autocomplete functions. So if you have to do an action repeatedly and it's difficult for the driver to do, like it involves a lot of buttons, and you can repeatedly redo the same, it's very easy to program. You can program an autocomplete function. So this year we had to build a tower in FTC. So we had an autocomplete function that let go of the stack and backed away in endgame, because we found that when there's 5 seconds left and you have to back away from a tower and not knock it down, sometimes there was issues with coordination if there wasn't enough time. So having that autocomplete function saved us the driver's time and stress. Fail-safe algorithms are a big one. Even when there's a mechanism you're not sure whether it will fail or not, having a fail-safe algorithm is always great. Whether that be like an intake that you need to make sure won't break, or it's, we had a problem with a robot tipping over last year. So we used the IMU to check the orientation of a robot, because we knew when we went too fast and stopped really suddenly, that's when a robot flipped. So because of the IMU, we were able to slow down our robot before it stopped, and that stopped it from flipping over. Teleop enhancements are anything that has easier control for the driver and easier control for mechanisms. And we like telling FTC teams to apply for the control whenever they can, because even if they don't have any complicated mechanisms, things that count for control include mechanism programming strafes, slow buttons, combining buttons for mechanisms, and thinking of how you can enhance your robot in Teleop is always helpful in terms of better control in game and getting the maximum number of points. Next slide. So yeah, this has been a brief overview of the FTC Engineering Notebook, the FTC Judging Interview, and the FTC Control Award. And we're ready for questions.
Well, we have a lot of questions. Our chat's really interested to see what's going on here.
All right.
Do you have any tips for a team who may be looking at doing an engineering notebook for the first time?
First tip I have would be consistency. So saying, when do I do an engineering notebook? And then sticking to it. So in FTC, we have to do an engineering notebook at every single meeting. And just staying on top of that, reflecting on that, and then making sure everybody in the team reads the engineering notebook after. So sort of having a schedule. And what we've also found helpful in using the engineering notebook as a tool is being able to reflect on it afterwards. So always before competitions, we'll have engineering notebook day, where we'll look through the engineering notebook. We always make sure we proofread like during the season and like sign all the entries, but we'll look through the beginning sections, which are the sections Joe was talking about, like the robot section, the programming section, and we'll all read through them, we'll all proofread them, and we'll all write things that we need to add.
So when you do this, it's like every single team member is involved in the notebook. It's not like you have specific students assigned to the notebook. I like that. I think that's probably the broader way to get it. I'm going to ask my co-host Ishan, since we have two Ishans, don't want to get confused. But co-host Ishan, do you have any questions for our team here?
Yeah, for sure. So as a community-based team, what type of challenges do you face that you feel that other teams may not face?
Well, as a community team, we all live pretty far apart, and let's see here. There's definitely more challenges. I'm just having a brain fart right now. Would anyone like to add?
Yeah, so like something that other community teams struggle with is sustainability, trying to find new team members. Our team has done lots of outreach and everything, so we do find them luckily, but it's just sometimes we had 2 team members on the team in the past, so it's kind of like close to like having a very small team. So just sometimes finding team members might be a bit challenging.
We have to do a lot of outreach to get team members, especially since the FTC community around us is growing a lot, which is really good, but it just means that there's less schools and places to recruit from. But we've got FLL, some kids come up from FLL. We try to have some sort of media footprint, and we've got a good community of people that we reach out to. but it's definitely sometimes a challenge to recruit team members.
We have another question from chat, and this is a good one because I know this comes up a lot, especially with new teams. Do you have a preference between the Rev kit versus the Tetrix kit, and why?
Our team actually uses the Tetrix kit.
Okay.
I know that Rev just came out with their own channels, which is better. I just didn't like the X Rails. That's my personal opinion. I just thought it was more difficult to build with.
Okay.
So, but the new kit I think is a lot better. So we just stuck with Tetrix. So
yeah, and on the topic, because we have, every FTC team in Ontario this year was new, and we're going to have a lot more new teams next year. So do you have any advice for new teams in terms of, what suppliers that you trust? Like, what are the go-tos for Fixit when it comes to building your robot?
Tetrix is easy to start with, but there isn't one that is the answer to all problems. Each toolkit has their own benefits, so find the one that fits your styles. So a good thing to start with is definitely Tetrix, but you can also combine different kits as well. So, example, we use Tetrix, but we also use the Rev gear, the Rev gear motor. We also use the Rev gear, the pole. I don't remember what it's called.
the X Rails.
Yes, the X Rails. Sorry.
We're lucky in that we have things from diverse kits, so we're able to mix and match.
Yeah.
Definitely most of our robot is made of Tetrix. If there's any FRC or FTC teams that are interested, we wouldn't mind setting up a Skype call and just showing how different things work, because it's definitely a team preference.
Yeah.
We keep saying Tetrix. There's a lot of teams that swear by Rev. I don't like X Rails. Some teams do.
Yeah.
Well, I want to say that offer is super, super generous, and I'd love it if maybe after your segment, if you can go into the chat and post how people can reach you and how people can connect with you, because I think you guys have a lot of experience that would be really helpful for our teams here in Ontario. And teams, obviously, you've been inspiring teams across the globe. So thank you so much for that. We do have only a little bit of time left, so going to try and hit some of these other questions in chat. Here's an interesting one. How has your team identity, skills, and approaches evolved through your 10-year history?
Oh.
So can you repeat that? I got lost there.
Yeah, same here.
How has your team identity, skills, and approaches evolved over the 10-year history?
This is when it's really good to have an engineering notebook as well. So engineering notebook, although it's really good for your season, it's also really good for past team members current team members to look into the previous team members and look at what they've done and how and what can be changed as well. Because it's not like you have to start brand new every single time there's a new team roster. It's good to take skills from each roster and see what went well, what went wrong, how we can improve on that.
And it's really nice because we have our alumni come into makerspace where we work out of, and they kind of teach us their stuff. Like during the summer we did different lift systems and stuff like that, because we thought it was maybe a stacking game. So they would all come in and they would all teach us their different techniques and what they've learned over their years. So we kind of get their knowledge passed down to us and different ways that they've solved their problems, so we can create our own way of solving them.
Thanks so much for that answer, and thanks so much for being on the show. This was really informative on the inner workings of an FTC team. You guys clearly have got a real recipe for success, and it's exciting, and I really appreciate that offer to help out teams who might be looking for it. So thank you for joining us, and thank you for all that. And before our next segment, let's just take a little look at this video from one of our sponsors.
The world is full of people telling you who to believe they are. Well, we thought we'd tell you who we're not. Let's start here. We're not in shipping. We don't make lifts. Seriously, no lifts. We do this. We're good at this. And we make all of these. And even though you'll find us here and here, we don't make energy. We make you save it. And you'll be saving the environment too. Are we an internet company? Well, we connect and power just about everything around you. helping machines talk to each other and to you, making your world more personal. We're seeking out the big questions and answering them honestly. Like, how can we make the most of our energy and resources? Or can we make access to energy and digital basic human rights? We're real people, employees, developers, partners, investors, and inventors, all passionate about doing what's right. We're open. Humans of all sorts from all over, learning from each other and about each other. We're not here to save the world. It'll go on with or without us. We're here to help power and connect what you do every day, to ensure life is on everywhere, for everyone, at every moment.
All right, and we are back and we're ready for our next segment. We've got a story time segment coming on right now. And we have, there you are, Ishan, I was looking for you. All right, so we're going to bring out our next guest, Brennan Bibic from Team 4476. He's a First Canada game announcer. He is an FLL alum. He's been doing this for a very long time, and he's now one of the most successful drive coaches out there. He knows his strategy on Team 4476. So welcome, Brennan.
Hey guys, happy to be here.
Yeah, thanks for joining us today. So, I briefly touched on it. You have a long journey. So where does your first journey start and where has it taken you?
Yeah, so I started on an FLL team in 2006 with NanoQuest way back when. And, we were a pretty successful first LEGO League team going to provincials and world championships twice, luckily enough. For those of you who don't know, first LEGO League is like incredibly competitive to make world championships. It's like, sometimes there are 0 teams that can qualify from depending on where your district is.
That's
so,
about as hard as it can get.
yeah, literally impossible. I guess FRC teams have a little bit of a taste of what that feels like, unfortunately, this year. But it is a challenge for the first LEGO League teams, and we were super successful. I actually started. One of the big influences was the back then there was a show on PBS called Zoom that had a big FLL kind of documentary series thing. So that's part of the reason why I got super involved, is because I saw that on TV and it was like, oh wow, this is really cool. Lego, something up my alley, super interesting. So I competed in first LEGO League, before high school, and then jumped into FRC. I guess my first avenue into FRC was in 2008 when we hung out with 1114 for their amazing season, and went to one of their regionals and got to see all the excitement of that. And I was super pumped after that to get into FRC. At that time we were just a small Lego team, so it wasn't like we're like, oh yeah, let's just pull like $15,000 out of a hat. Not exactly not exactly something that we could do at the time, but luckily there was a Kingston team that started in the following year in 2009 at KCVI that I was able to join. 2809, now 2708. They merged with another local team, so I started with that team and was an operator my first year, and then dove into the strategy components post that, and some of the scouting. And in 2013 we decided to start our own team to try and facilitate the people who were not from KCVI, because at that time there's only 2 schools that could take team members. So we had a community team that we started, the Waffles, which was also based off of our first LEGO League team. So I've been with them ever since. We were was a student on that team for a couple of years, and then have been mentoring ever since. So that's kind of like brief history, I guess.
A brief history of Brennan. It's been a very exciting one. I definitely remember you as an FLL student going all the way back to those competitions at provincials when I was back at St. Mildred's, and
yes.
then coming to Worlds. in 2008, you there with your robot, and then that was, that was probably the best possible year you could have joined up with
Yes.
1114 at that point for that amazing run. I still have videos of all of us watching the fireworks together.
Yes, that was amazing. We were, at the time I didn't really understand the importance of that moment either, because I'm just like, oh, it's our buddies and they just happen to be winning everything, so yay, go 1114. But yeah, it's interesting to reflect back on a lot of the memories, even like starting in FRC originally. You don't really grasp the kind of magnitude of what kind of effort is being put in and what kind of things are happening. You look back at teams that you play with before when I was first few years, and I'm like, oh yeah, we played with 254. I just thought they were just some random team. It's not
right.
You don't think about those things until you really kind of understand that. I remember when I was still in First Lego League, and they had the live streams for 2007, which we didn't make it to Worlds that year, watching the streams. And I remember I tuned into FRC competition in 2007 for Rack and Roll, and I remember thinking this is so boring, show me the FLL stuff. And just to think a year later, I'm like, oh my goodness, this is crazy. It's interesting.
I think the reverse also happens to some of us, where we'll be at FRC champs to focus on FRC. We'll be at champs, sorry, not FRC champs, it's first champs. We'll be at first champs to focus on FRC, and then we'll randomly see an FTC match or an FLL match, and we'll not realize it's oh, that's gluten-free. They're just the best FTC team in the world, and they just broke a world record there. Or I remember, because I didn't really truly get into FLL until I met the Waffles. That's when I started following more, and then I understood back then the power of a 400-point score.
Yes.
And I remember witnessing those in person at Worlds, and it was oh, this actually happens. This is a thing. And it was it's cool to see things from the other side.
Yeah, definitely. I think a lot of first or FRC people don't really understand the amount of work that goes into the other programs for sure. A lot of these students are putting in, same amount of hours as a regular FRC student or one of the key FRC students. So, and that the same thing I'm sure goes for FTC. I haven't, been a part of that, but all of those things, it really adds up, and it's really crazy. I remember there's this one team at the World Festival, they called it, and they were a knockoff of the Blue Man group, except they were the Green Man group or whatever. And they played music in their pits, and then they went onto the field and scored 400 points. They just they never had anything to do. They were never practicing. They're just all right, and we're playing music, we're entertaining, and then we go onto the field and then we just get a perfect score.
Were they one of the teams who would just do it one button and it would go, or did they have to? Because I remember there was one year, Brennan, and I think maybe you were the one who showed me this video, but there was one FLL team, they just put the robot down on the field, one button, and it would drive back to the base and attach its own attachment.
Yes.
And it was I was like, what is this?
So a good story about that actually is one of the teams that we connected with pretty early on was Mindstorms Mayhem, now Mechanical Mayhem for FRC team.
FRC, yeah.
And they were a previous Champions Award winner at the world level for FLL before they transitioned into FRC. So we actually went down to New Hampshire to see them compete in 2006. And one of the teams there, actually that team, the first team ever to do it, they put the robot down, they pressed a button, and it ran away and did everything, got a perfect score just by pressing once. They never even had to touch it. The robot picked up its own attachments, and just to kind of give people an idea of how much that means for people who aren't really initiative, they were on the RCX, which is one of the biggest things. So they had a limit of one encoder. So good luck, FRC teams. Doing a crazy 20, 30 turn autonomous mode with one encoder is insane. And never touching it, dropping off attachments, parts of the robot, picking it up. And one of the cool stories is that team that was kind of their whole goal for that season, is to do it in just one button, get a perfect score, one button. They talked to there's a person in New Hampshire that was really well known for helping new coaches and that kind of thing, and they talked to him about it, and they're like, hey,
Ken Streeter.
yeah, I'm not sure, I couldn't remember. I can't remember his name. I think he was a FL exclusive at the time. But anyways, he talked to this team, and the team was like, hey, do you think this is possible? And the mentor was like, I don't really think so, guys. I don't think that would be, you should probably just do it normally. And the kids were still like super, they just wanted to do it, and they pulled it off. And I happened to be there at the time when they pulled it off. So it was like absolutely insane. That was like my second competition ever. So being able to see that and see that the kids, what really resonated to me is the kids kind of said, you know what, we're going to kind of upset the expectations, and adults said, hey, you can't do that, or that's not possible, and they did it anyway. So that was really cool for me to see, for sure.
I mean, these are like some of the stories that are just so great and so exciting about all of this. Ishan, what do you think of all this? Do you have any questions for Brennan?
Yeah, for sure. So you have so many different experiences that you've already highlighted. So we'd like to ask you, what's your proudest moment in first?
Yeah, proudest moment. Well, there's been a lot of them. I think most of them, for me personally, relate to Waffles is in a unique position to be able to mentor students for a long age range, more than just FRC. Since we have the FLL Junior program and FLL program in-house, we've had several students now that have gone through literally every single program. So a lot of the students, there's a real connection there for me, being able to start them with just basic building or teamwork in FL Junior to like building crazy autonomous modes or a brand new robot. So each of those students are really important to me, I guess. So those are the most important things, I guess.
And Brennan, you've been around for a long time, and what we try and do on Storytime is just try and give people a little bit of insight into some of the stories that they might not really know. Is there a story you'd like to tell about a match you've been a part of or been around, or anything in FRC?
Yeah.
Or first Lego League, please. The FLL stories are great.
Yeah. Well, I guess we can jump to FRC. It might be a little painful for 1114 viewers, but we
1114 has had so much pain over the years. Unless the story is going to be your robot got hacked on Einstein. Yeah, exactly. Yeah. See, after that, nothing really hurt. Nothing. It's just like, yeah, it could always be worse, So.
Yeah. We were really fortunate in our second year of competition in 2014 to have a very successful run at GTR East. And we're not like a high resource team, and at this point we had even less resources than we do now. We were drill press and hand drills and like a chop saw. So especially having had that relationship with 1114 previously, with them like winning world championships, and then seeing some of their amazing successes, going into 2014, we we didn't have the rookie all-star to kind of bail us out for like qualification, and this is back when there's regionals. So at GTR East we had a super successful run where we were able to win the event against a really competitive 1114 and Dave. They were both actually undefeated at the time too, and I remember going into alliance selections and being like, okay, well, we're just gonna go as far as we can. We're gonna have fun with it, no big deal. But we ended up getting a really good robot on the way back up that could finish cycles and actually shoot.
2198, right?
2198, exactly. And one of the big reasons why we saw them is because we saw them on the practice field doing their autonomous modes and hitting them reliably. And having them left up on the way back up was really insane. So coming out of eliminations, we're like, okay, this is a pretty solid alliance, but we did well in our quarters. We weren't really worried about the quarters too much, but going into semis, I remember we were against 1114 and Dave, and it's just like, all right, so let's just have fun with this, guys. We'll do as much as we can. We're gonna play. One of the big things that we had noticed is the third alliance member. For those of you who don't know, 2014, there's a really important scoring aspect of you had to pass there's a big yoga ball that you had to pass between all three robots to get the maximum amount of points. So
you needed all three robots to be able to do something, which was very different than pretty much any game that we had seen up to this point in the 3 versus 3 era.
Yeah, you could normally just kind of, just score a whole bunch of points by yourself. You didn't really have to interact with other people very much. So having that kind of aspect, and then we had a previous match with the who ended up being the third robot on the 1114 and Dave Alliance, and we're like, well, maybe we can kind of exploit that a little bit and block them from passing their ball. Because one of the big things obviously is the passing. So once the ball's in their robot, then there's a whole bunch of mayhem trying to get that ball passed, or perhaps you have to call a dead ball, and then that whole stuff happens. It's really confusing. Anyways, we won't dive into that, but it basically would stop the alliance from scoring. So basically that was our only avenue of trying to pull it out, and we ended up playing a lot of defense and preventing them from passing effectively, and that caused us to be able to win the first match, which was insane. Going into that match, we were just like, all right, well, if we can make it close, I'll be happy. And then the second match too, I remember 2198, they had a compressor leak in their pneumatic system, and as a result, they couldn't start in frame perimeter. So they were like freaking out, and they're like, "Oh, it's over! We screwed it up. I'm so sorry. We're up 1-0, and we're gonna play 2 versus 3." Reassuring them, making sure that they're like, "Hey, it's okay. Don't worry about it. We're gonna just, we'll try next time for the third match or whatever. No big deal." And then unfortunately, because of one of the ways that the penalties work, there's some penalties assigned, and we ended up barely winning that match as well. So, pulling out that one was kind of very surprising. And I remember going into finals and being like, okay, oh yeah, there's still finals that happen. The semifinals felt like the finals for sure. Even though we still had a job to do in the finals. And that was also the first year we were with 1285. So that was the first year of 1285. Yeah, they built the same robot as 1241, but that's actually another funny story. The coach from 1285, Gagandeep, he was the driver for their 2013 World Championship run where they actually won. And one of the things that he immediately said, so we had previously played against them at the same event in 2013, where we played defense against them, and they were not really able to score very well. They got like one cycle in, and then immediately after, once we picked them, then we kind of had this realization that he was driving for them and I was driving for us, and it's like, wait a minute, you're the guy that made me look. And he had been teased by 1241 a lot because of that. So because there's like some random rookie team that made them look really stupid, and then it's like they're supposed to be this like really amazing team. He's like, oh, you're that guy. Yeah, so that was amusing.
Yeah, that's a cool story, Ishan.
Yeah, for sure. So moving on, where did you go to school and what did you study, and why did you choose to study that?
Yep. So I went to UOIT. It's now named Ontario Tech something.
Ontario Tech University.
Yes. And I studied engineering for a few years, and then I realized that you know, one of the things that actually ended up happening to me is I had really thought that engineering was my thing, and I had considered like doing other things, but because of FRC, I was like very like, oh, I got it all in on engineering, and it ended up not being the right fit for me. So I've actually transitioned into IT, which is kind of more up my alley. I like working with computers and programming stuff. I do a lot of system administration and stuff like that. So that's what I'm doing now.
Yeah, I think there a lot of people don't necessarily realize this, but there are similarities between engineering and IT because at their core they're both about problem solving to a certain degree, and it's with engineering you're dealing with physical situations while IT you're dealing with like network type situations. So I don't think it's
Yes.
too big of a difference there. It's just more that the medium that you're using and then the computers and
Yes.
stuff might have just kind of fit to be more up your alley. You've told us a lot of stories, Brennan, and you've had a lot of experience as a mentor. Is there one piece of advice that you'd like to give to the students watching today?
Yeah, it kind of relates to the same thing about the story I told about the team that pressed the button and did it by themselves. If I had one story to give or one advice to give is don't be afraid to try things and kind of say no and give things a shot, especially when people are saying like, I don't know if that's really, I don't know if you're capable of doing that. One of the biggest things that I learned that I wish every student could learn is that you can do whatever you want, really. You put enough effort in, you put enough time in, you can really achieve excellence if you're really invested in that kind of thing. So, yeah.
Mhm.
And you again, I keep saying this. You've been doing this for so long because you just have this like really really cool story. Has there been any one person who's inspired you the most, or an inspirational story that you might have for us?
Let's see. One specific person?
Or it could be a team, a group. It could be, we're just talking inspiration here.
Yeah, I there's so many different people. One of the big things that I'm invested in is scouting stuff. So working with 1114 back in 2012, I was with them for an event. Working with them for scouting, Waterloo
Yeah, I remember
that. Was super eye-opening for me. One of the big things actually too, with back when I was an FLL kid, with 365 Mo, we were queuing up for first league, and I can't tell you how much of a deal this meant to me, but like they were like, they did this chant of like, hey, we got Spirit, how about you to us? Yeah. And having an FRC team be like, hey, FLL people, you're cool, like that was like, wow. And they are like, they're building these amazing, crazy robots that I can't even understand right now. And the fact that they have time to kind of like be like, hey, that FLL team, you guys are awesome for doing what you do.
That's pretty sweet. So we're got a little bit of time here, Brennan. So we're going to take some questions from chat. One of the questions is actually from our next guest, Shifa from Team 188. What advice do you have for alumni wanting to return to mentor their old teams?
Yeah, so I think this is fairly common advice, but I think you should maybe hold off on mentoring your old team for the first year. So I actually kind of long distance mentored for 2 years after I graduated, and I think a lot of that comes down to it's hard to mentor when you have other students. Like there's kind of two things to it. It's hard to mentor when you have other students that are already on the team that know you as a student. There's kind of a you want to make sure that you're able to be kind of separated from that zone. So they will treat you as a student, and you might feel obligated to kind of like act like a student. They're kind of different roles. And then the other thing is, try volunteering. That's super awesome. I game announce. We didn't really talk about that much, but that's okay. I game announce. There's lots of amazing roles you can get that are really fun. I started with field reset, so that's also cool if you want to see the field side action. Try different things, try new things, maybe join a different team.
Yeah,
for
I think
sure.
that. Well, please, Ishan.
Yeah, I feel like that's completely true. And moving on to the next question, what skills do you think best translate between FLL and FRC?
Yeah, that's a really good one. So one of the biggest things is the programming skills for sure. A lot of the FLL concepts are very transferable, and especially as you get like FLL has grown so much since when I started. The teams are insanely good, like PIDs and like really complex programming for these younger kids
Oh,
are very common.
When you go to the World Festival and you see what these FLL robots are doing, it's like
it's insane.
Whoa! It is. This is like industry level stuff.
Yes. So like these kids that they can learn so much, especially on the programming end, to really transition into FRC, making FRC teams like programming size better, and also just like general workforce. Like you just learn that much when you're really like being super competitive and trying to chase that, being as best as you can be.
Brennan, we are running down on time here, but I guess one thing we'll do that we'd like to do with a lot of our guests is we'll kind of change it up a little bit here. Do you have any questions for myself or Ishan?
Yeah, Ishan. So this is your second year of doing this.
Yeah.
What do you think about what's been your favorite experience for yourself, or your team is also kind of somewhat new. 2016, I think you guys started. What's your favorite like team memory or like experience that you've heard about or.
Yeah, for sure. So for me, I'd actually say it's probably my first robotics competition, just because the first time you go there, you're just so surprised to see how much spirit there is and how much there's going on, and to see like all the work you've been doing for those 6 weeks actually come together and sort of work together with other teams, help other teams out, and just collaborate together.
Definitely.
Yeah, I think everyone, that's kind of a not so unique thing to always talks about the first time they walk into an event and what it's like, just kind of that whoa experience, because it's always bigger than you can imagine. No YouTube video, even a 118 robot reveal video, can truly give you the scope of what it is. So it's it's special to see. Brennan, thank you so much for being on the show with all these stories, from FLL all the way up, and talking about what's inspired you and how you've inspired others. And thank you for being a great volunteer, and thank you for everything you do as a coach and a mentor. It's really cool to see, especially as someone who's known you since you were so young. It's really special. So thanks a lot, Brennan. And now,
thanks.
Before our next segment, let's take a look at a video from one of our event hosts.
My Western experience so far has been phenomenal.
My experience at Western this far has been unforgettable.
Astounding.
Unique.
Very memorable.
And it kind of just picks you up in week one and says, get out here, don't be afraid to be yourself.
Western really lives up to the #1 student experience.
You really get the sense that you are part of something here.
What I love about this place is that everybody here loves it.
Everyone takes pride in being a Western Mustang.
Yes, you come to university to learn and study, but as well you're here for the other things that the university offers.
Being part of clubs, being part of teams.
Western is this great campus, and there's so many opportunities.
Everything is there for you. When you see the juggling club, you see the dancing clubs, you just see everything you could possibly want.
I want to experience something new, and I want to try things that I've never tried before.
To meet new people, meet great professors.
Professors here are awesome.
They tend to be interested in what you're interested in.
And they really try hard to make you feel welcome.
The importance of having this student experience is really that it's something that's going to last you for the rest of your life.
When I think of Western, everything is possible.
I want everybody to have, the same great experience that I've had here.
And when I stepped on Western campus, it just felt right.
And we are back, and it's time for another Storytime segment. So I'd like to welcome our next guest, mentor and alum from Team 188, 180 Great. It is Shifa Abbas. Hey, Shifa.
Hi, how are you?
I'm doing good. I'm pumped to hear from you here. So let's start right up at the top. Tell us where you started from at first and where you ended up,
Oh
and
man,
everything in
okay.
between.
The longest story. maybe not longer than yours. But,
I think you just called me old. I think you just
I
called me old.
So I was on an FLL team in grade 7 at Churchill Heights for 2 years. And that's where I started. And then I moved on to Woburn Robotics, Team 188, where I was for 4 years, where I did the chairman's team and the administrative team, and I helped out with scouting and strategy. And after I graduated, I went on to study at the University of Waterloo, where there was this amazing little first-year team started by some Robotics and Woburn alumni called Team Dave. And back then, 3,000 teams were like the youngest, you know? So, so I joined them, where I mentored them for another 5 years. And then at that point, I had moved back to Toronto, and Team 188 was in need of some of the alumni to come back for just like sustainability. We had a teacher strike that had made it really difficult for the team to keep going. And I've been there ever since. And in the middle, I've been volunteering, and I was volunteer coordinator at Waterloo for a little while. And then I was helping as an event assistant. So I've been part of FIRST for a really long time, probably longer than I haven't been part of it. So the vast majority of my life has been part of FIRST.
It is a little bit strange when you hit that point where you've been done more than half your life in FIRST. It kind of hits you. It's like, oh, this is, or like when you realize it's like, other than my family, like I've done FIRST longer than like I know anyone, you know, it's very, like there's nothing in my life that I've done longer than FIRST, like even like my education now. Like,
and it's where you found like your friends, where you found another part of your family. It's where you spent the most of your time.
Yeah, it's weird what started as like an extracurricular that you're just kind of like, okay, I'll try this out, you know, like I never would have like, imagine if like one of the other extracurricular activities that we did back in the day took over. It's like, yeah, like imagine if I spent 23 years doing yearbook, like.
If I could never quit student council.
Yeah, really. Oh, that'd be a bad one to be stuck on. I guess it's like running for government at that point, you know?
Yeah.
So there's people who do it, and that's a whole other world right there. Ishan, what do you think of all this?
Yeah, for sure. It's amazing. And I like I mentioned before, the first time I went to my first robotics competition was incredible. And I'd like to ask you, over your experience for so many years, what was your proudest moment in FIRST?
So I think coming from 188, you see a lot of your fellow alumni and your classmates go on to other teams and help out. There's always been 188 alumni that go on to mentor other teams. That's natural. One of our alumni, like some of our alumni went on to 2056, and some of our alumni, like even I went back to or onto Team Dave. But one of the most proudest moments that I had was when some of my students from Team Dave went on to help other teams. So it was like coming into a competition and seeing like Danny, who was the youngest student I had ever had. I was like first year university, and he was like a grade 7 that we had like gotten onto the team, and now he's like a Celtics mentor and like behind the glass. So I think one of my proudest moments is like getting to see that legacy. And I know I've been that for lots of people, and now I get to see that, like I get my own students that I get to be proud of that are now full adults.
It is the family tree sort of thing where you can trace down the lineage, you know, of like and like you said, it like with 188, where there's been so many of us who've gone on places, but you think that like Mr. Brennan mentored me, and then I went to 1114 and like mentored Tyler Holtzman, who then started, you know, 2056, and like you just see this like chain of everywhere. It's so intertwined, but at the same time, what I find really neat is that sometimes you'll have a team pop up that's not linked to any of these other teams.
Yes.
But they still somehow like have the same sort of energy and spirit and vibe, and it's just kind of contagious through our programs. So it's really neat to see. seen a lot. You've been around a lot, and you're just one of those people who just like always kind of knows what's going on. So I want to know like a story that you have for us, Shifa, that like the audience might not be aware of, or something really cool that you've seen, or an interaction or a dynamic or something.
I think what I would say, especially for the younger students like that are watching today, it's once you've graduated. I know Brennan talked about it a lot too, but the idea of like volunteering gives you this behind the scenes kind of aspect that you have no clue of. So when I was in FLL, I had no idea what went into starting and creating and then running that competition. And then when I got to be on 188, I got to run one of those competitions and give students that opportunity. But what I found the most interesting was when I was at Waterloo, and then I got to work on the regional planning committee. I got to see like the whole other side of that action. I got to interact with the judges and the volunteers and spend an entire weekend with all my friends and watch the best robots that season. And I got to see what exactly it takes to create that amazing environment that I know, Ishan, you probably get to witness. And when you get to kind of produce that, it's an amazing feeling.
Yeah, for sure. So moving on to the next question, more personal to you. So where did you go to school and what did you study?
So I went to the University of Waterloo, which is also Karthik's alma mater.
Water.
Lou.
Yeah, you know how we do.
So I studied biotech and microbiology, after which I did my Master's of Education. And I was working for a private school. So I took some time off to do an MA at Wilfrid Laurier. So I've been kind of everywhere, but I chose Waterloo because I knew I needed to be at a hub of that still took that robotics. I definitely wasn't done by grade 12. I know I was just getting started. So I wanted to go to a university that allowed me to have that community. And that really helped first and second year when, you're missing home and you're missing the wonderful family that you left at 188, and you're able to like ingratiate yourself into like a new one.
And so you mentioned there that you've gone into teaching. What motivated that, and what's that experience been like?
So I think when you start off as an FLL mentor and then ultimately an FRC mentor, you realize the ways in which teachers specifically can mold a child's or a student's entire career path. So many of the teachers that I had growing up inspired me to become a teacher. One of them is Sean Lim, who was at the time, and I think 2011, was a student teacher at 188, which was his like alumni team. And it was seeing how much one person can inspire, a group of 20, a group of 30. And then I was able to take something that I loved doing, which was mentoring, and then like take it and make a career out of it.
Yeah, it's really neat to see the students who come through this program and the different career paths they take, because it's like, I think a lot of people, and Brennan touched on this a little bit, kind of come in, it's like, oh, like you go into FIRST because you want to be an engineer, but there's so many different paths, and because there's so many different facets to the program, it's only natural that there would be so many different paths that people take. And it's really cool. Like, and you're the second alum turned teacher we've had on the show. We had Matt Coffey on last week, and it's really kind of cool to see the impact that all of you are having. I'm just like, I can't wait for 15, 20 years from now when we have so many FIRST alumni in teaching that it's going to help change education. And education is going to be more like a FIRST team where the project-based learning and all that sort of good stuff, which is a lot of teachers are already bringing into their classroom. Like, let's not kid ourselves. It's not unique to FIRST, but there is something special about that. So seeing those sort of dynamics. What about the FIRST experience have you been able to bring into the classrooms you've been in?
I think it's the overall networks that you create once you're on a team, and that's why your alumni base is so important, because you as one teacher have access to people in so many different fields and so many different career paths that you're able to take their experiences and you're able to share that with your students. So you end up being this hub of knowledge that can hopefully help students with what they're interested in. I know even as a mentor, we're able to kind of help with career guidance and answering some of the questions. I know on 188 we have entire structures in place where we can help students with their university applications and then help them with like finding co-ops, and that's why your alumni base is so important to cultivate and keep, because those are the relationships that end up being like the most fun but also the most rewarding.
Yeah, for sure. So in terms of like guidance, like you're talking about already, what type of advice would you give to for students right now? I
think it would be that in the time that you're competing, obviously you're creating these wonderful relationships with your teammates, but you're also, I would encourage you to extend that and then make friends with students on other teams, and then keep those going, because those are the ones that once you graduate, whether keeping connected to that program is so important, because whether it's just through your alumni group on campus or volunteering at an event or two, that's where you end up with those co-op opportunities with resources for the team that you're on now, and those connections that you create. So when I was on Team Dave, the connections that we had with 188 and 1310 and 610, those are the ones that really help you out.
Yeah, I think one of the things that's really interesting, and you mentioned about like finding those co-op terms and those connections that you build, is that when you go when you're in school, like you see everything in these very linear terms. It's like, because the process for going to applying to university is not about connections at all in Canada. It's just you fill out your OUAC form and you sign up, and you get chosen. Like if you have good enough grades, you get to go to these schools. But I think a lot of people don't realize is that and even the co-op process can be a little bit misleading, because you have this system where there's all these jobs posted, you apply, and then typically the people with the highest grades or like the best work term ratings get these jobs. When you go into the real world, it's not really like that. Sure, there's some jobs that are like posted and it's well defined, but a lot of the times the coolest jobs, you find them just by meeting people. And networking is like, and it can be hard, because for especially if you're an introvert, networking is painful, but it is so valuable. And like if you talk, like I get this question a lot. It's like, how did I end up being the global competition manager at Vex? And it was like, there was no job posting for any of this. It's just like people that I had met, and just I chatted with them, and they were starting up something new, and they're like, oh, this is something that Karthik would be really good at, and just getting your name out in front of that sort of stuff. And so for everyone who's watching, I think it's really important. Like one of the things about FIRST is you have access to such amazing people and such really like mentors who are doing crazy cool thing, and they get to see you doing crazy cool things. And so if you've designed like this super cool gearbox, you want to show that off to people on other teams, because one of them might be a mentor for a startup that's doing autonomous trucks and might say, hey, you come work for me.
Exactly. And I think it's just so amazing to see that happen in real time. So the people that I graduated with, it's like this dynamic network of people. I know Noeen is one of the students that I graduated, I think, a year ahead of, and the job that he has now where he's teaching came from FIRST Robotics. And so many times it's like talking to somebody like Karthik or Mr. Brennan and asking if they know anybody that's hiring. And so many of my friends like got their first opportunities in that way. And there's nothing like FIRST on your resume to kind of help you out. There's been so many interviews that I've gone into where they'll ask, oh, do you know so-and-so person? It's like, yeah, through FIRST. And that's like in any field that I've been in, not necessarily just specifically STEM fields either.
Well, and also it speaks to the importance of how you conduct yourself at events, because these things come up, where like you might be in a job interview and they'll be like, oh, FIRST, yeah, I know Shifa. It's like, oh, I think I've met her once. That person who's interviewing you is going to text Shifa and be like, hey, do you know this person? And that sort of reference. And Shifa, like, if they remember, it's like, oh yeah, they were like really polite about like, picking up their garbage in the stands, or it could be the opposite. Like, oh yeah, like I asked them to put on their safety glasses and they just gave me this cut eye and went, like,
Exactly.
So like, but every little interaction matters, especially in this community where like, in general, it's a very positive community and people are going to say good things about each other. Like that's, like people aren't like making naughty lists or anything like that. But at the same time, if you really go that extra, if you treat everyone like they're Mr. Brenner, where it's like, oh yeah, maybe they can do, like if you treat everyone with that esteem, you're more likely to have these burgeoning connections that all come to you. So it's like,
and I would say a lot of the students, especially me when I was in high school, and then every student that I've mentored, we're not necessarily the most like extroverted, the most naturally social people. But I think what FIRST does is give you a community of really warm and welcoming people that are able to kind of help you through it. You're not going to go up to a mentor of another team and get this like crazy negative response. You're going to get something very positive, and it's overcoming those fears that kind of help you out, not necessarily just in FIRST, but in the rest of your career and your life too.
Yeah, it's very cool. So Shifa, you and I have a lot in common, but one of the things we have in common is we both have a shared passion for social justice and taking care of those who are less fortunate at all. Can you tell us a little bit of the work that you've done in the Malvern community supporting our youth in STEM?
Right. So one of the really cool opportunities that 188 got was working with Malvern, which is a neighborhood just a little bit away from us, in creating FLL teams and junior FLL teams through the various community groups and churches that are in that community. And so what 188 was able to do is take this really great program that has helped so many of us and worked with the youth that maybe don't have that kind of access. And it's just so amazing. We had the Malvern Church FLL junior team come to the FRC provincials last year, or sorry, the like first Ontario provincial championship.
FOPC.
FOPC, not DCMP anymore. And they got to see this like amazing group of students doing something that they were only 2 or 3 years out from. And it really changed the way that they thought about how they're hopefully going to have FLL teams in the future. And so we're currently in works with them to do that.
That's really fabulous. Ishan, do you have any questions?
I'd like to ask, so do you have like any I don't know, any like skills that you believe that FIRST students they sort of show to like like when you're progressing from FLL to FIRST, what type of skills do you think that you'd need to translate?
So some of the skills I know specifically, so we do a lot of work in scouting and strategy, but sometimes what happens is you'll have something that you want to run, and now you have to work with 2 other teams in order to get that done. Or you want to run a scouting meeting and convince somebody or convince your team that the decisions that you're trying to make is in the benefit of the team. And so what I think FIRST brings, or FRC brings, is this ability to be convincing and to back it up with statistics and data. Is that kind of where we were going? Are we talking about the transition from FLL to FRC? Yeah. So I think for that transition, it's it comes down to cooperation. So it comes down to, a lot of us are really great in the classroom and really great at working one-on-one. But in working with a whole team, it's a lot more difficult. And what FLL does is teaches you how to leverage everyone's skills and leverage everyone's strengths and use it to the team's benefit. And that's something that's really important in an FRC team as well.
And Shifa, I know you've done some initiatives working with people overseas. Do you want to let the audience know about some of that? Like, this is just like cool stuff that we all need to hear about.
Cool. So last year in July, I spent 6 months in Djibouti, which is in East Africa. And I was working with the Ministry of Education and the Ministry of Commerce there as a gender equity officer. So primarily some of my work was just involved in promoting gender equality through workshops and trainings for the teachers there, for the ministry officials. So what I found was that a lot of the connections that we had made in working on gender equity in FRC on Team 188, specifically recruiting more women, making them feel safe and engaged in a tech environment, was something that I could then transfer on to my work in international development.
So working as an expert and a specialist in gender equity, and thinking to what you've seen here and first domestically, what obstacles do you think there are to getting girls to join teams, and what do you do as a mentor to help reduce those obstacles? Because I've worked with 188 the last couple of years and seen the team, and there's been a definite dynamic shift, and I can tell it's probably something to do with your influence, but you have so many smart and talented young women on this team who are really leading the show there. So I'd love to hear more about what you've done.
I think what it comes down to is representation. So when I started off in FRC, there were very few other girls that I could see on other teams, very few people that looked like me, people that wanted to do the same things as I did. But what has happened in the last 10, 15 years is those alumni that come back are able to create environments where we feel represented and we feel like a lot more comfortable. And so one of the things that 188 does is pair people up, and that's something that we took from Symbotics, is that little bear, big bear partnership, where we're able to.
We called it Big Symbot, Little Symbot.
Yeah, you call it little
bears.
so we use the bears,
Right.
but it's the idea of creating this, creating conversations and tackling the issues that you inevitably will face head on. So I had a really great group of mentors that I had access to when I was a student, and then we just try and recreate that for the new generation.
The bear thing's absolutely killing me, because for a while we did refer to Todd Willick as Papa Bear and Taylor as Baby Bear, so it really does fit.
I think that's just a testament to the knowledge exchange that we've had over so many years, is that you always know where the trend started, but you don't know where it'll end. So even on Team Dave, when we had Lee as a mentor, he taught us that Symbotics used to, before a strat meeting, they would have a little giggle. Everybody would talk about their favorite funny moment from the regional.
Yeah.
And then we took that on to Team Dave, and now we try and do that on 188. And so there's just amazing. If we ever got into all the little knowledge exchanges, we would be here for a really long time.
The knowledge exchange is just so freaking cool.
Yeah.
Because you look at it in industry right now, where you have these, it's almost maddening right now, because there's a shortage of ventilators, and there's all these companies working separately, developing, to try and increase the ventilator supply right now. But it's just almost man, if these companies could share their, now is not the time for patents, and now is not the time for exclusivity. But first teams of we've thrown those barriers away a long time ago, where it's just you go up to a team and I know the 188 experience, Kajivan would just always come up to me and just be like, hey, so what do you do with this? Or what do you do with that? And just wanting to soak things up and learn. And that's how true improvement comes. And you wonder why technology evolves so rapidly in FRC, because it's all these links together. It's not happening in silos. And those silos are just they can be totally destructive. So.
And I think that's the really great part. I know yesterday Praneet was talking about how there was a era when I was in high school where there were no wild cards, there was no district championship, and it was just you had to be the best spot and you would get a spot at World Championships. And that just elevated not only the relationships that we had between teams, but also the standard and the level that people compete at. And it's without that era that I think even Ontario First or First Canada in general wouldn't be where they are now.
Well, and I also think it was because there have been people have always asked, how did Ontario come up so quickly? How did Ontario come up so quickly? And I think part of it is because we've had so many alumni returning to mentor their teams. So lessons weren't lost. And obviously it was the excellence of 11, 14, 20, 56, pushing people to other levels. But there's been other areas with teams, similarly excellent, but the push wasn't happening. But also it was because those two teams were sharing so much.
Exactly.
And then the teams who came up very quickly, the 610s, 1241s, 188s, were also sharing. And there was just like this big network, and like knowledge wasn't being, not only was knowledge not being lost, knowledge was just, like whipping around this circle.
Definitely.
And by the time it came back around to those original teams, it had gotten better. And
Definitely.
and it was just like boom, and like that's where the spread of talent has come from in Ontario. So.
And I think it's a lot of it was us not being embarrassed or hesitant to ask for help too. So it was, hey, Karthik, like we're on a chairman's team. We don't know how, you're obviously on a Hall of Fame team. We don't know how to bridge that gap. We don't know how to get any better. And it was like 2 years of your feedback that got us, you know, a 2010 chairman's banner. Or so it's like definitely a lot of none of that hesitation, because none of that really helps. Or it's, you know, and even at Durham, we had a rookie team that hadn't scouted, and it was time for them to pick. And it was like Makeshift who was like, oh yeah, we'll give them our scouting data. So it's that knowledge exchange exists whether you know it or not.
Right. It's just like the natural thing to do. We are running down here on time, but Ishan, do you have any other questions for Shifa?
Yeah, for sure. So what do you think Karthik was like as a mentor?
So Karthik, so the story, it goes that Karthik was, he had mentored us for FLL back when I was on Churchill Robotics.
Because Shifa and I went to the same elementary school, just a couple years apart, only a couple years.
Only a couple, like they're not even, it doesn't even matter now. So it was Ocean Odyssey. And what we had done was we had created this like, well, it would have helped now, but it was like the system of like reinforcements that would like help some like oil tanker not spill into the ocean. And so what we had done was we had asked Karthik to come back to help us out. So we had presented this innovative idea to him. And there was just such a line of questioning that like was posed to us, and we had no clue how to answer half of them. And so we had stressed ourselves out to a point where we just needed like a good cry, and that cry was then like helped out by like hugs from Karthik. So inevitably he like made us cry and then helped us out. But it's like that kind of pressure cooker mentality that like we were born out of, that like got us to where we were. And the same thing happened, you know, 3 years later when I was on the chairman's team. With like Karthik asking, so like, really, you haven't done anything since this last year when I asked you this to present for me? So Karthik is like the greatest mentor in that he like calls you out when he needs to, but also provides you with like all the support and love that you need to.
You know, it's about trying to get the most out of people, and you know, because I think for any of us to really not just succeed, but to reach next levels, we have to push our own boundaries. And sometimes we need someone to help us find where our boundaries are, because it's as I think anyone recognizes, it's about finding a task that's just a little bit too hard for yourself. And that's going to force you to go a little bit further. Because if you're always doing things that you know you can do, you're never really going to extend yourself. And I think that's kind of part of the challenge there. Shifa, we could go on for hours. You realize that we really could. So thank you so much for being on. This has been really cool, and like, thank you for everything you do, not just for your team, but within your community and abroad. And I'm excited to see what you're going to do next. And like, literally, I want to have you on a show like at least once a year to know like where Shifa's journey has been going.
Oh, that'd be so cool. Thank you so much for having me.
Great. Yeah, for sure. Before we get to our next segment, which is going to be a team and robot showcase with Team 2200, let's take a look back at the 2019 Detroit Championship. right, we are back and it's time for another exciting segment, and we've got a good one right here. It's a team showcase with Team 2200 MMRambotics from Burlington, Ontario. They've been doing first since all the way back in 2007. They're winners of 3 blue banners, including the last 2 Durham College District events. They're one of the best up-and-coming teams in Ontario, maybe not even up-and-coming anymore, because I think they've definitely hit the top level, especially this year at Durham. So I'd like to welcome on our reps from Team 2200. We have Jake, we have Alan, and we have their mentor, Adam Bocek. How's it going, everyone?
Yeah, it's going pretty good.
All right.
My name is Jake. I was the lead design engineer and one of the mechanical members this year. I also drove in 2019.
I'm Alan. I was the driver this year, and I was one of the lead programmers.
And I'm Adam, and I've been mentoring the team since 2008, and I was a student on the team on 2007.
All right. Well, let's give the people what they want. Let's learn a little bit about this 2200 robot.
Yeah, sure. Hey, perfect. So we're a team from Burlington, Ontario. We're a quite large team. We're 72 students. We have 19, give or take, volunteer mentors and 3 teachers that help run our team. We're fairly well equipped mechanically. We really run our team as a design and mechanical team. We're over the last few years, we've really been pushing to expand sort of the spaces we have in the school and the resources we have for our team to try to get our team to that next level. And we'll see some of that as we go through the slideshow here. If you want to hit the next slide there.
Yeah, so a little bit about our robot this year. It's named Recoil. It was right on the weight limit of 124.9. 24 by 36 inches. We went for a small and compact design that's capable of going underneath the control panel. We have a pretty fast exit shot velocity, like Karthik always says, 60 kilometers an hour, and it looks better in red.
Alan, is that 60 kilometers an hour theoretical, or is that measured speed?
As you'll learn about later, we did do some math for some of our programming. So yeah, that is calculated.
And calculated by factoring slip, or?
Yeah, I can answer that. It does factor in some slip between it, yeah.
Okay, because I was going to say, I'm positive your geared speed is definitely faster than 60 kilometers an hour.
Yeah, I think theoretical, if it leaves the shooter perfectly with no slip, you'd be in the 80 kilometer an hour range.
I would have guessed higher, but please go on.
We'll get to that.
Yeah.
So a little bit about our design process during kickoff day. Now, this is one that I think we do maybe a little different than some teams. Is we get together with all of our teams from our school board, and we have kickoff together. So there's 8 or 9 or 10 teams now in the Halton School Board, and we all gather together and watch the kickoff video, and then we all sort of split up into our own teams and start the design process. And I feel like a lot of teams on kickoff day jump right into, oh, we could build this, or oh, we could build this. We try very hard to stop our team from trying to think about what we want to build on day one. And we more focus on learning the rules of the game and focusing on trying to think outside the box on different ways the game can be played. And one of the methods we do to make that happen is a few of us as mentors purposely won't read the rules. We'll divide the team up into 4, 5, or 6 groups, depending on how the rules are laid out that year. And each group has to teach us their section of the manual to the mentors. What that does is it really forces a conversation about what are we allowed to do this year and what are we not allowed to do this year. We try to keep it short. We only spend maybe 3 hours doing this, and it's always a good time. And some of the best parts about it are some of the students coming in, the next day, and you overhear them talking about, I really couldn't get it through their head how this game's played. Because the students know, and we're trying to pretend that don't understand the rules, to really force a large discussion about exactly how the rules are laid out. So that's it on that one. We can hit the next slide.
Yeah, so when it comes to prototyping, we're definitely very active on a year-to-year basis. This year, we were definitely more active than some past years, really trying to lock in, finding the best shooter that we could. Our shooter was a bit unique with the 2 dual wheels. We'll get into that a little bit later as well. The best way to describe it would be to give a quick outline of our season's kind of plan. So week 1 is really fully focused into prototyping, looking at a few mechanisms, kind of trying to lock in some rough ideas. Our week 2 would be our just full-on design, going every day, basically just going crazy, trying to get the CAD finished up. Never finished on time, like everyone, but we do our best. Weeks 3 and 4 are manufacturing based. Week 5, we kind of put it all together, and week 6, it's off to the programmers. We do build 2 robots. We have our practice robot and our competition robot. Our comp robot is usually, say, about a week behind the practice robot. We use that kind of week of difference to kind of thrash the practice robot, drive it into the ground, figure out any mechanical programming faults in it. And then we do have a bit of leeway, a bit of time to be able to implement any changes we want in the competition robot that won't really harm our schedule at all. So this year, we really tried to, like I mentioned, trying to focus on some shooters. You'll see here a few different iterations. I think we had about 4 different designs of shooters from there, change, RPM, wheel size, compression, a bunch of different things until we found a repeatable shot that we liked. So the bottom left, the video there is one of our later prototypes, probably the most similar to what you'd see on the robot, design-wise. So you can go ahead and play that. Yeah, so we did have a lot of designs like that, kind of shooting from a tabletop, just trying to mainly check reliability of the shot. It hits the same spot every time, just so we can lock it in, things like that. One thing that we do as well is in the bottom right, that's what we called our proto bot or our test bot. And what we did is once we figured out a shooter design that we really, shooter turret design, we really kind of locked in, we actually built a model of it out of aluminum, and we gave it to the programmers in the most similar way it would be on the robot. We gave it to them, and then they went off and were able to actually get a lot of the programming and control systems done in the early stages of the season, so they weren't as crunched for time at the end of the build season. So you can play that. That's just implementing some early camera tracking and shooting code there.
Yeah, so as that continues to play, I'll go on to the programming side of prototyping early on in the season. So this year we actually started a new program where in the 2 months before kickoff, all of the programmers actually joined a class where we got really familiar with all of the FRC components on a practice board that you can see in the bottom left. It's the white plywood board, has all the components that we need throughout the season. So we made a bunch of test code and blocks of code for each component to really get familiar with everything. And what the practice board actually allowed us to do was on the first day, we just sat down with the prototype. We were able to run it in a pretty close to accurate way with PID. So it really helped for prototyping. We were able to get accurate results early on. And then we were able to use the chunks of code that we had written before later on in the actual program.
I think we can hit the next slide there.
Awesome. So getting into our drivetrain, probably the biggest thing to touch on here is our motor selection. We opted not to go with Falcons this year. We're a team that rarely adopts first-year products. We usually like to get kind of a basis, kind of more than some early testing, but a full season of run on some products. So this is our first year using Neos. We stayed on Sims last year. We're off Neos this year. Which is really definitely a benefit. We've kind of realized because, last year with the Spark Max errors and this year with all the problems the Falcons are kind of throwing, Karthik, you'll be familiar with that. So this year we've been really happy with the Neos. It's our first brushless motor. It's really great. We're a huge fan. But when it comes to the drivetrain, we did do standard two Neo 2-speed shifting gearboxes. So when it comes to our gearing, we do have our low gear of around 7.5 feet per second and our high gear of close to 15. We did do an 8-wheel tank drive, and this was our first year making our gearboxes relatively fully modular, so they can very easily come in and out, which we definitely utilized a few times when making adjustments or fixes after Durham. So that was really nice. One thing about our drivetrain that is a bit different to majority teams is our integration with side plates into our actual chassis. The majority of the robot is designed around basically 4 plates, where almost every mechanism is intertwined and integrated into. It's really nice because they act as our drive pods, and our intake, our shooter, our gearbox mounts, everything is all in these plates. Gives our frame rigidity, and overall very simple. We run kind of a unique, not West Coast drive, but kind of a modular design, which is pretty cool.
Yep. So again, moving on to the programming side of things, we use 3-bore encoders on the output shaft of our gearboxes. And we chose to put them on the output shaft because when we're shifting in auto, or if we were to shift in auto, we wouldn't have a loss in counts. So it's mainly for accuracy in autonomous.
Is this the new Rev 3-bore encoder?
Yes. Yeah, that is one of the examples of components that we took on in the first year.
How do those encoders work out for you this year?
They work
I'm sure
very
the
well.
audience is curious to learn from an early adopter.
So we tested them on the practice board right when we got them, and they just worked very well. They're very robust, easy to wire. So yeah, it worked well. And then moving on, we use the WPI curvature drive class, just with a few alterations for teleop, for more fine control for the driver. So yeah, moving on to the next slide.
Yeah, so when it comes to our intake here, this was definitely one of the things we fiddled with the most. The bottom left there, you'll see our first iteration. Bottom right's our second iteration, and our top right is our final kind of what we're planning on going with. One thing that you'll notice is we very often use carbon rollers in our intakes. One of our sponsors is able to provide those for us, so it's definitely something we use quite often. The one thing we did notice with them is that if they take a hit, they can crack or they can break. So usually we run a hex bar all the way through the roller. So if we do have a fault or any damage to it, the intake will still function. Just run off the hex bar instead. So if you look in the bottom left, we have our 3 roller design. Our first iteration was a linear pattern, but what we realized is, one, the bottom roller wasn't quite low enough, and the middle roller, there's a bit too much compression on the ball between the front of our hopper and the intake, and it was really bogging down and slowing down the intake. So what we did for our second design, which is the one we ultimately used at our week 1 event at Durham, was a bit more of a curved pattern for our rollers. We dropped the bottom roller about half an inch to add a bit more compression on picking up the ball off the ground. And then we alleviated some of the resistance of the middle roller just by moving it out a little bit to kind of prevent those jams and bogs downs. One thing we did notice is that there was a few spots where the ball would get stuck. So with our third design iteration, we added our ram bar across the front, inspired by 1114, and to kind of prevent any damage to the carbon rollers, as well as we moved the side plates for the intake to the inner side of the 1x2 to prevent any snagging areas where the ball can kind of get caught up. One of our also main focuses with the redesign was reducing the weight, making it lighter. The side plates were awesome for rigidity, but they were kind of a bit heavy. We opted to go to kind of the polycarb route to save some weight there.
Not a whole lot to say on the programming side of the intake. It goes up and down, in and out.
What else do you say about an intake?
Yeah, what else do you say about an intake? The only thing that we can say is that we gave the intake controls to the driver this year, which we usually put to the co-driver's task. And it's not a huge task for the driver to be driving around and picking up balls. Well, the co-driver's focus needs to be focused completely on shooting. So they need to be looking at when they're available to shoot, like giving information to the driver where to drive. So we found that it wasn't a big task for the driver to take the intake. So we gave that to the driver this year.
Also, in general, I find that the intake is natural for the driver because they're the ones who are pointing the robot at the game pieces anyways. So it's kind of like it eliminates one extra step of communication. So when separating tasks between driver and co-driver, I really like to try and make them as discrete as possible to minimize the amount of pauses that have to happen. So that's just a very natural move right there.
Yep. Next slide.
All right, so this is probably the most, I would say, unique version or mechanism in our robot. I haven't seen another hopper like this. So one of our main kind of, as everyone found out with the early testing of the game pieces, is that they don't like to interact with each other all too much. So we wanted to kind of avoid contact between the balls as much as possible to prevent any jams. And so we kind of prototyped tons of different ideas when it came to driven, not driven. And we settled on a kind of a gravity assisted sorting. That's probably the best way to put it there. So what we do is when the intake hands the balls off to the hopper, they're kind of let free to find their own path and to kind of fall into either channel or barrel of the divided hopper. When there are 5 balls in there, 1 is stored underneath the shooter, and then we have 4 stored side by side in the actual barrels or channels themselves. We do have omni wheels that drive the balls into the shooter. We'll use those for the ability for the balls to center themselves with the least resistance possible, again, to prevent jams. What we found is you can't really force a ball somewhere where it doesn't want to go, right? No matter how much power you throw at it, because ultimately you're going to get a jam if you don't do it perfectly every time. So having that gravity feed, we were really happy with it. We prototyped several different options, holding them linearly. You can see the bottom left, an early prototype of the hopper we decided to run with. What's also nice is that where the intake hands the balls off to the hopper, there's no kind of covering on top. So if, how we lift up the intake, or if 2 balls kind of get in there a weird way, if there is to be a jam, instead of forcing it into the channels, the balls will just kind of pop out the top, which sometimes those pop up right next to us, we'll pick them up again, or they'll kind of roll. It doesn't really matter, but it prevents jams from entering the robot. It just kind of alleviates them and forces them outside, which is really helpful. Yeah, play the bottom video there. You can see some of our feeds.
Yeah, so as that's playing, we have 3 sensors, 1 underneath the middle ball and 2 underneath the ones closer. So we automatically index our balls while they go in. So as soon as 1 enters the hopper, it'll index to the middle omni wheel. And the robot makes its own decision based on how to feed. So in that video, we didn't have it set up yet, but we figured out that we could save time shooting by alternating the feed, because we could save about half a second in between the second and third ball from one channel rolling by alternating and starting to feed from the other side. So we made that change after this video. So it encourages alternating, which helps to save time on our shots.
Cool, I think we can hit the next slide there.
Yeah. All right, so our turret and our shooter, like I mentioned before, we did kind of have tons of iterations with our shooter options. Like I mentioned, we settled on the dual wheel design. We have 2 4-inch Fairlane wheels with custom press fit hubs. They are each individually powered by a 775, the bottom wheel running at a 3-to-1 production, and the top wheel running at a 4-to-1. So the reason we settled on the dual wheel shooter is because we wanted to be able to get that higher exit velocity to hit the long shots, as well as be able to control the backspin on the ball in order to get that reliability. When you run with the flywheel, you're really kind of leaving it to slip to control backspin, but with the ability to run at 2 different RPMs on the 2 wheels, we have that finite adjustment to kind of really lock in the reliability of the shooter. When it comes to the turret, we have 175 degrees of rotation to the left or to the right, sorry, and 135 to the left. It is one thing that's really kind of neat about our turret is that it is a fully bearingless turret. It's run off 8 acetal rollers that we machined in-house to reduce weight, and it's also a really cool project for our students to learn on our CNC lathe. We tried it, and it was really smooth. We were really happy with it. So.
Yeah, so the shooter is definitely the biggest part programming wise of the robot. So we opted to use static wheel speeds no matter where we are in the field. So 4,500 RPM on the bottom, 2,250 on the top. And we control everything based on the tilt. So if we're farther away, then we tilt accordingly. It's controlled using closed loop feedback, using just P and F, proportional and feed forward. We use through boring encoder to get the tilt counts, and we have a little limit switch at the bottom of the tilt, just in case something goes wrong. If it gets bumped, then we reset the encoders to 0, and it's kind of like a fail-safe. And so a big focus of ours was trying to be able to shoot while we're under defense. So we included, by doing some projectile motion calculations and some vector calculations, we included shooting while driving. So we get the distance from the limelight, we get the speed of the robot, or the velocity of the robot based on the encoders on the drivetrain, and we also take the angle of the pan of the shooter. And we take all these variables into account to do the calculations, and that proved to be very helpful while under defense at Durham. We found that since we focused more on the positive feedback loop, staying in the opponent's zone most of the game, it kind of just fit our play style to be able to shoot well under defense. So that was really beneficial to us. And then something to mention, after our first competition, we realized that 3-point shots were a lot more important than we first thought they were. So we implemented some parallax calculations by retrieving the 4 corners of the target that the limelight sees. So within 2.5 degrees of either side of the goal, we aim for the 3-pointer instead of aiming for the middle of the target.
We are running a little bit close to time here, so I want to make sure we see all these awesome videos that you put together.
Yep. If you want to hit the next slide there. I think what we'll do is we'll talk really quick about the climber here, just so we can get through it. It's a simple 3-stage design. And the only sort of extra notable element about it is we use the versatile ratchet stages, but we used a pneumatic piston to release the ratchet. I think that was just a bit of a unique design. I didn't see it anywhere else, but it worked out really well for us. And you can play the video there.
I almost think with these telescoping style hangers, it's kind of like an intake at this point. It's like, what else can you say? Because they're become so ubiquitous now.
Yeah. One thing that I would like to note is our telescoping arms were designed and built entirely by students on the team. There was no mentor involvement at all in them, which is considering they were the one aspect of the robot that just worked the entire event, didn't need any repairs. I'm pretty proud about that.
Yeah, massive shout out to Brad. He's the guy in the bottom middle there. I don't know how many times we came back to him and we're like, yeah, Brad, we need to redesign the packaging on these arms. Like at least 4 times. But yeah, he was every time he's like, okay, what am I gonna change? And so like massive shout out to him. It was his baby and they were amazing. So
and then if we could hit the next slide there, we'll just show our various autonomouses, because we are running out of time here.
Let's take a look at these. When was this video filmed?
This was filmed the day that the schools got shut down.
So after Durham.
After Durham, yeah.
Because I did not see this at Durham. That is so sweet. Oh my, ooh, so good.
Yeah, the video that's showing right now is an auto that we wrote between qualification and eliminations at Durham. And it really speaks to the way that we write our autos.
Sorry, Adam, yeah. The video's kind of stuck.
Yeah, it did get stuck there.
Yeah, but I mean, these autos, these are definitely the best autos 2200s ever had in the history of your team. Like, there's some really complex pathing there, and the accuracy, not only on the shot, but the pathing was really impressive. So that was cool to see.
Yeah, the Limelight's been a game changer for us, for sure. So
for everyone.
For everyone, yeah.
Yeah, it's a good thing, that's for sure.
And just one last thing to touch on really quick is on our team, our drive team is different every year. We never have the same students 2 years in a row. And I think that's maybe kind of unique, but we really hold the drive team position as, you know, a bit of an honor to the students that put in the extra effort on the team. So it is a bit of a handicap that we give ourselves, but we work through it. We give them everything that we can to make them as good as they can in the time that we have. We leave our practice field open so they can come in at lunch, during spares, whenever they want to come practice. So.
Well, yeah, I mean, it's working, that's for sure. And I think you can do a lot in a short period of time with drivers, especially now with the new relaxed rules about the bag. I think there's, you know, a lot of different things you can do. We are running out of time here, but there's one question from chat we want to get to. If you could change one thing about the robot, restart the season, we're giving you the full time period, what would you do? And this is a really good robot, so this is a hard question.
It's hard to say.
Yeah, that's a tough one. We're pretty happy with how it's competing. I mean, there's always small fixes. You know, the intake could be better.
Yeah, those small things are the kind of ones I want to hear about right now.
I guess the big one was the intake redesign that we already have started on. That was probably the biggest or the lowest hanging fruit, I think is the way you call it.
Anything for you, Jake?
I would say not really a mechanical side of things, but one thing we did definitely talk about after Durham was one, really kind of trying to get some better autos. Our autos were pretty good at Durham, but they weren't overly consistent. So we wanted to really nail in our 6 ball. And then as you see, we programmed that 10 ball. And one of the big things we did to after Durham on the programming side of things was improve our 3-point percentage. At Durham, we weren't really shooting for the 3 goal. We were just really shooting to get it in. And if one went in the 3, we were like, hey, fantastic. But we really focused on after Durham, I want to say pretty immediately was, okay, let's kind of get this 3-point goal really locked in, because those are definitely going to be crucial this season going forward. But yeah.
Right, of course. Well, thanks so much for joining us, Team 2200. This is a fabulous robot, and really glad we got to see it compete week 1, because this robot deserves to have that showcase and shine. It's absolutely amazing. So thanks for being on. Thanks for sharing your tips and tricks. And yeah, thank you for doing that.
Thanks
and now it's kind of time to wrap up the show. Ishan, what did you think about what we had today?
I think it was amazing. I really loved the different designs and mechanisms you used, especially the hopper. It's pretty unique to your team. Thank you.
Yeah, and we had a great host of guests. So thank you to everyone who was a part of the show today. Tomorrow, we've got a lot of story time. 3 story time segments. We've got Team 5885 alum and Dean's List finalist, Erica Rossi. We have a First Canada volunteer coordinator and MC, Team 771 alum, Marie-Jo Bacot. And of course, we have a Team 188 alum, Shifa mentioned him today, and the drive coach for Team 7558 and Instagram influencer, Noeem Kashif. And a robot showcase, we had a Durham College champion yesterday. We're going to have the Georgian College champions, Team 865, Warp 7 tomorrow. So it's going to be a great show. Thank you to everyone for being on. And remember, everyone, stay safe, wash your hands, and keep having fun. Talk to you tomorrow.